Biostatistics, Introduction and Basic Definitions. Content of topic includes basic definitions of data, statistics, biostatistics, and variable. Data is a collection of raw facts, figures, observations, or measurements of experiment or survey. We observe information or data about particular phenomena, and from these observations, we attempt to increase our understanding of the event that the data represents. If the data collected originally by the investigation or experiments is termed as primary data, for example, clinical trial results, results from lab tests. If data is utilized which had been earlier collected by someone else, it is termed as secondary data, for example, scientific journals and public health statistics. Types of data. The two main types of data are qualitative data and quantitative data. Qualitative or categorical data is a type of data that cannot be measured or counted in the form of numbers. These types of data are sorted by category, not by number. That's why it is also known as categorical data. The qualitative data are further classified into two parts, nominal data and ordinal data. A nominal data is used to label variables without any order or quantitative value. These data do not have any meaningful order. Their values are distributed into distinct categories. For example, gender of a person, types of tablet defect. The ordinal data have natural ordering, where a number is present in some kind of order by their position on the scale. For example, passing class as second class, first class, and distinction. Quantitative data is a type of data that can be expressed in numerical values. The quantitative data are further classified into two parts, discrete data and continuous data. Discrete data are countable and finite. They are integers or whole numbers. For example, number of patient in a clinical trial. Continuous data are in the form of fractional numbers. Continuous data are measurable. For example, weight of tablet. Methods of data collection. There are two methods of data collections. First is census method. This method includes 100% inspection of the population in experiment or survey. Second method is sample technique. This technique includes to inspect only a selected fraction, finite subset of the population. After obtaining results of the sample data, we draw a conclusion about characteristics of the population. Statistics has been defined differently by different authors from time to time. Statistics is the discipline that is concerned with the collection, organization, analysis, interpretation, and presentation of data. Statistics is the acquisition of knowledge through the process of observation. Statistics is the branch of mathematics that transforms numbers into useful information for decision makers. Types of statistics. There are two main types. First is descriptive statistics. Simple meaning is which describe data. The branch of statistics concerned with the summarization and description of data is called descriptive statistics. It includes construction of graphs, charts, and tables, and the calculation of various descriptive measures, such as averages, measures of variation, and percentiles. The second type of statistics is inferential statistics, having complex statistical tests. The branch of statistics concerned with using sample data to make an inference about a population of data. Inferential statistics includes methods like estimation, hypothesis testing, and making predictions, which are all based on probability theory. Descriptive and inferential statistics are interrelated. Methods of inferential statistics can be used in data obtained from descriptive statistics to make more thorough analysis of the subject under investigation. Definition of biostatistics. Biostatistics is the application of the mathematical tools used in statistics to the fields of biological sciences and medicine. Applications of biostatistics in pharmacy. To design biological experiments. To define what is normal or healthy in a population, that is health research. To find the relative potency of a new drug with respect to a standard drug. To design an analysis of the clinical trials. To find an association between two attributes like disease and smoking. To identify signs and symptoms of a disease. Definition of variable. Variables are the measurements of values that are characteristic of the data collected in experiments. Types of variable. The two main types of variable are qualitative variables and quantitative variable. Qualitative variables are variables that are not numerical and whose values fit into categories. Qualitative variables are divided into two types, nominal and ordinal variables. A qualitative nominal variable is a qualitative variable where no ordering is in levels. For example, the variable gender is nominal because there is no order in the levels. Same way, another example is types of tablet defect. A qualitative ordinal variable is a qualitative variable with a natural ordering, that is, order implied in the levels. A good example is health level, which can take values such as poor, reasonable, good, or excellent. Again, there is a clear order in these levels, so health is in this case a qualitative ordinal variable. A quantitative variable is a variable that reflects a notion of magnitude. That is, it's the values it can take are numbers. A quantitative variable represents thus a measure and is numerical value. Quantitative variables are divided into two types, discrete and continuous. Discrete variables are values. Those are countable and have a finite number of possibilities. The values are often integers. For example, number of children per family. It will never be 3.58 or 7.912. So the number of possibilities is a finite number and thus countable. On the other hand, quantitative continuous variables are variables for which the values are not countable but are measurable and have an infinite number of possibilities. These variables come with values that are fractional numbers with infinite possibilities. For example, weight of tablet. If we weight a 3-gram tablet, in weight balance, we may get an infinite result based on accuracy, like 3.0 gram, 3.04 gram, 3.045 gram, 3.0452 gram. In biostatistics, discrete and continuous variables are commonly observed. Discrete variables can take on a countable number of values. Values obtained with ordinary counting numbers, like 0, 1, 2, 3. Continuous variables can take on any value within some range or interval, that is, within a specified lower and upper limit. Value is obtained by measuring the total number of possible observations or results, which is the sensitivity of the measuring instrument. For example, weight of tablets, temperature for enzymatic activity, pressure. Other class of variables that can be found in regression are dependent and independent variables. The variable whose value is influenced or predicted by other variable is dependent variable, also termed as regressed or explained variable. The variable which influences the value or use for prediction of other variable is independent variable, also termed as regressor, predictor, or explanatory variable. There are 4 types of scales of variables used in biostatistics. First is nominal scales. In nominal scales, the variable is in the form of categories that do not have a natural order or ranking. Computing a mean, median, or standard deviation is not possible. For example, gender, blood type, disease types, drug brands, or types of formulation. The second type of scales is ordinal scale. Ordinal scales used to measure variables in a natural order, such as rating or ranking, but not forms measurable differences between values. For example, overall status, poor to excellent, cancer stages. In analgesic studies, scores are commonly assigned to pain severity, such as no pain equals 0, slight pain is equal to 1, moderate pain is equal to 2, and severe pain is equal to 3. Although the scores cannot be thought of as an exact characterization of pain, the value 3 does represent more intense pain than the values 0, 1, or 2. The third type of scales is interval scale. Interval scale is used to measure variables with equal intervals between values, this enabling precise comparisons and calculations. Examples of interval scales include temperature in Celsius. Temperature does not have a true 0 point and is an example of an interval scale. A temperature designated as 0 is an arbitrary position on the scale and does not represent the lack of temperature. We cannot say that 40 degrees Celsius is twice as hot as 20 degrees Celsius. The fourth type of scales is ratio scale. Ratio scale has a clear definition of 0.0, means absolute 0 point. Comparisons and computations are possible, such as ratios, percentages, and averages. You can add, subtract, multiply, and divide values on a ratio scale. For example, age, weight, and concentration. A person who weighs 50 kilograms is twice as heavy as one who weighs 25 kg. You can refer to these mentioned books for this topic. Fundamentals of Statistics by S.C. Gupta. Pharmaceutical Statistics, Practical and Clinical Applications by Sanford Bolton. Please take a note on important study questions. Thank you.